Now that we've covered linear equations, we're going to look at linear inequalities. So let's do a couple of basic examples first. An inequality is just a statement that is going to be greater than, less than, greater than or equal to, or less than or equal to. So with our equations, we had answers like x equals 3. With linear inequalities, we might have something that looks like that instead. And let's look at how we would plot that on our number line. So that's when we're graphing it. So x greater than 3 means that 3 is our border. You'll notice I'm putting an open circle there. We're going to talk more about that coming up. And I then put an arrow that indicates the solutions for that inequality. What are the numbers that would satisfy x being greater than 3? Well, 4, 5, 6, all of those numbers. So what we do is we put a line with an arrow that tells us that every solution to the right of 3 would satisfy this condition. Now, let's look at a different example. What if this were x is greater than or equal to 3? Now I'm saying that anything that's larger than 3 or equal to 3 is a solution. So the big difference here, folks, is that we would fill in the circle. So we're saying that 3 satisfies it and anything to the right of 3. And similar to that, if I had x is less than 9, we know that our values start at 9, and now we would draw an arrow, a line with an arrow that implies the solutions that would also satisfy that inequality. Let's think of numbers, 8, 7, so anything to the left. And then we draw that arrow, and that shows any number smaller than 9, anything to the left of 9, would satisfy that. If this were x is less than or equal to 9, what do you think we'd do? Exactly. We would fill in our hole. So before we dive into more examples of solving linear inequalities, let's just take a look at these two numbers, 3 and 7. If I were to put an inequality in there, what would make that a true statement? I hope you said less than. That would be right. So now, folks, think about this scenario. Now, what if I were comparing the negatives, -3 to -7? Do you recognize what happens with the inequalities? It now gets reversed. So we're going to talk through a couple of steps that we take to solving our inequality. So we notice when we're solving our inequalities, and then we'll graph our number line for the solution, we would, 1, treat that inequality just like we would an equation. I want to get that variable by itself. But if we multiply or divide by a negative value, then we are going to flip the inequality sign. So now that's one thing we want to be mindful of. And then the last of those, we use a closed circle if we're greater than or equal to, less than or equal to, open if it's just greater than or less than. And then our arrow tells us the direction that would make all of those a true statement. So here we go. We're going to try a few of these examples together. So let's look at question 1. We want to get that x by itself. So our first step would be, let's move that 7. So we're adding 7 to both sides. And when I do that, we have 6x is greater than or equal to -12. I want to get x alone. So now I'm dividing both sides by 6, +6. So that inequality stays put. That leaves me with x is greater than or equal to, and -12 over 6 simplifies to -2. On our number line, we would put, I like to put 0 just so that it's there. That's my origin. -2. So x is greater than or equal to -2. So I know I have a closed circle because it's or equal to. And what would be greater than? Greater than would be values to the right of -2. So why don't we try 4? Looks a little bit messier. 4 reads 8 minus, in parentheses, 5h minus 3 is greater than 5h minus 5 minus 8h. So here I know this is an understood 1. I'm writing that because I'm going to distribute that -1 to both terms. So that becomes 8 minus 5h, and minus 1 times -3 is +3. And then I write everything else out. So the next step is, just because I want to simplify things, I'm going to combine the like terms that are currently already on the same side of the equation. So I have 8 plus 3. So that's going to give me 11 minus 5h is greater than or equal to, and here I'm also seeing I've got 5h minus 8h, so that gives me -3h, and then minus 5. Great. So now I'm going to combine like terms, and I'm going to group them. So let's move the 3h. So we've got plus 3h. And that's 11 minus 2h is greater than or equal to -5. I want to get h by itself. So maybe I'll subtract 11. I don't have to change the sign because that was just subtraction. And that now, that goes away, gives me -2h is greater than or equal to -16. Now what are we going to do? Now we're going to divide both sides by -2. What happens when we divide or multiply by a negative number? We now have h is less than, we're flipping that sign, or equal to 8. So let's graph that solution. So if I were to graph h is less than or equal to 8, it's or equal to, so I've got my closed circle, and less than goes to the left. And let's end on 5, just so that we see a variation of these. So here again, that's a -1, so I'm going to rewrite that and distribute the negative. That gives me -1x, I'll write that as -x, and plus 5/2 minus 4x. And then again, we see like terms on the same side. So we've got 1 is greater than -x minus 4x is -5x plus 5 over 2. I'm going to move the 5 over 2 to the other side so I can get x by itself. And 1 minus 5/2 is -3/2. And if you did that on Desmos, maybe it gave you -1.5. I'll use a decimal for this. Is greater than -5x. All right, so now I want to get x by itself. I'm dividing both sides by -5. And when I do that, I'm dividing by a negative. I'm going to switch my sign, and -1.5 divided by 5, Desmos is going to tell you, is 0.3, is less than x. So folks, if I want to write that so that it reads as x is greater than or less than something, I'm going to remember that my inequalities are like alligator mouths, and they always want to eat the biggest value. So the x is the one that wants to be eaten. So I want to make sure that I keep that inequality so that it's going to chomp at the larger number. So if I have 0.3 is less than x, that is an equivalent statement of x is greater than 0.3. And if we were to graph that on our number line, we would have an open circle, and greater means I go to the right.